Hi, good morning, everyone. Can you see my screen, everyone? Online guys, can you confirm anyone? Yeah, fine. So we have completed three sessions, right? So in last four sessions we completed. So like DevOps introduction, technical questions, general questions, and cloud introduction, AWS introduction, right? And also SDLC, software development lifecycle, right? So these four sessions are very, very important. So those who are not attended those sessions, right? So can you WhatsApp me or can you call me so that I provide you previous recordings? Okay. Yeah. So last four sessions are demo sessions, introductions only, right? So but those are very informative, right? So don't miss yeah, just go through the recordings, and if you have any questions you can take down and you can ask me so that I clear your questions. Okay. Last week we discussed, last week fifth our batch started, right? Fifth, sixth, seventh, eighth, four sessions completed. Fine. So those you can go through the videos whoever not attended. Fine. Yeah, from today we are going to start server basics, servers, networks, right? Load balancers and IP addresses, subnet mask, gateways, routers. These are all very important for cloud engineers. So if you understand these basics, you can easily understand cloud infrastructure, cloud environment, right? So that is why these basics are very, very important. Yeah, these basics are on premises resources, on-premises basics. On-premises means local server room on your office premises. On-premises means on your office premises. Fine. So if you understand these basics, you can easily understand cloud infrastructure, cloud basics, cloud storage, cloud servers, cloud network. Fine. So before going to cloud, first we need to understand these basics, right? Yeah. So anyone newly joined today, can you share your WhatsApp number and email address in the chat so that we provide you previous recordings? Yeah, we provide you notes, don't worry. We provide you all the documentation. So wait for 1 or 2 days. We provide you all the documentation. Okay. We have a Google Classroom. So we give you Google Classroom access. From that, you can download the documentation. You will get the recordings also. You can go through the recordings also. You can download the Google Classroom. So once you register, so the registered people can get access on Google Classroom. From Google Classroom, you can download all the recordings. Right. Fine. So my mobile already provided mobile number 96422111711. This is my number. So everyone can take down this number, and if you want to have that recordings, previous recordings, so just WhatsApp me or call me after this session. So I provide you all the previous recordings. So those are very informative. So go through the recordings. Fine. Yeah. So today's agenda here is what is server, types of servers, server and client model and best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, IP address, subnet mask, gateway, router, firewall, failover, load balancer. These are all very, very important. Yeah. So today up to here we are going to discuss. So up to here it will take 1 hour nearly. Yeah. So today we discuss about this basics. So from tomorrow we tomorrow we'll work on this networks. Okay. So today we are going to work on the servers. So tomorrow we'll work on network basics. Fine. Yeah. So basically, what is server? What is server? Anyone having idea? What is server? Server is a computer, right? Server is a computer. Simply you can say server is a computer, right? But server will have high computing power. Server will have high computing power, high CPU, high memory, high storage, right? Yeah. So integrated controllers, integrated network controllers, RAID controllers. So advanced features will be there, right? servers will have advanced features. So we are using desktops and laptops, right? So in our personal laptop or desktop we are using. So but server side, when we talk about server is having high computing power, so high storage drives. These are the drives, these are the storages, right? Fine. So let's try to understand definition here. So what is a server? Is a computer that serves information to other computers. Server is a computer that serves information to other computers called clients. So clients and what is client and anyone having idea? So client is nothing but it is a either laptop or desktop. Servers can serve the information to other computers called clients, can connect to a server through either a network or either a local area network or a wider network such as the internet. So normally in real-time projects, every project team they're using servers. Why they are using servers? So because so the data will be stored in the server only. We don't store in the local systems. We store in the server only. So because server will have redundancy. What is redundancy? Anyone having an idea about redundancy? So redundancy is nothing but in case one disk is failed, so application will not be down, server will not be down. In case one processor will be failed, so server will not be down. In case one memory module is failed, server will not be down, right? So which is nothing but a redundancy. So server will have more capacity, more drives, more memory modules, more CPUs, right? So for example, if you take any hospitals or any schools, so what we will do? So normally when you go to get the appointment or anything, for example, if you go to a hospital, so when we go to OP, right? So we give the details. So when we give the details, they store the details. So the details will be stored in the server only, server, that will not be stored in the local system. So that is why, for example, when you go to any other floor or any other floor or any other counter, you will get the information. So if you give your name or number, so they can track your information, right? So server can store all the data centrally. So this information, this data, we can access through local area network or wide area network or any other Wi-Fi also. Any network, right? So LAN, WAN, MAN, any networks through we can access. Fine. So normally in IT companies, projects, so every developer develop the code, right? So in their local systems, once they develop, they push the code to central server so that everyone can access from central location, right? So code will be pulled, pushed, merged, right? Yeah, modified. So in the central only, because server is having more redundancy. Redundancy means in case one disk is failed, data will not be lost anywhere. Fine. Yeah. So next one, types of servers. What are the types available? So here we have three types of servers are available. So these are the traditional servers. These are the traditional physical servers I'm talking about, right? So currently we are not using, still people are using, but very less servers we are using. But currently we are using cloud infrastructure, cloud environment. So first one is a blade server. What is blade server? What is rack server? What is tower server? Let's try to understand. See here. So Blade server is a modular server that allows multiple servers to be hosted in a smaller area. So this is a container. This is a container. Instead of this container, we have inserted some blade servers, thin servers. These are the thin servers, right? Yeah. So these servers are physically thin and typically only have CPU, memory, integrated network controllers, and sometimes storage drives built in. So normally, blade servers will not have any storage. But without storage, how can we store the data? Blade servers will not have any storage, but how can we store the data? How can we install operating system, right? So blade servers, normally what we will do, we connect external storages like EMC storage, Dell storage, NetApp storage. So external storages are there. Those we can attach to the blade servers. So blade servers are often seen in large data centers. So enterprise level, we use this blade servers, enterprise level, right? So next one is a rack server. So rack server is a server mounted inside of a rack. Rack servers are physically, typically general purpose servers that support broad range of applications and computing. So these most of the data centers they are using this rack servers. So data center, what is data center? We know, right? Data center is a server room where we host all the servers, right? So data center is a server room. Fine. Yeah. Next one is a tower server. This is bit older server. Tower server is bit older server. Tower server is a computer that is built in upright cabinet that stands alone and that is designed to function as a server. So in this tower server, only one CPU, one monitor, keyboard, mouse will be connected, right? So this server is traditional server, bit older server. So currently we are not using this tower servers. So few companies they are using rack servers. So most of the companies they are using blade servers, right? So these are the traditional servers, right? So next one, client server model. Yeah. So this is the server we can access through network from, yeah. So this is the physical server, for example, physical server. These are the desktops. We can access our server through network. Either it can be LAN, local area network, or wide area network, or Wi-Fi, any network, right? So when we send request to the server, it will give response. When we send request to the server through network, will give response, right? So this is client server model. So most of the companies they are using client server model, right? So we can use currently we are not using desktops. Most of the companies, most of the project teams they are using laptops only, right? So through laptop we can connect our servers. So even though we are not using LAN connectivity in real time projects, right? So every company they are using Wi-Fi only. So even you can carry your laptop to cafeteria also, canteen also, breakout area also, right? So through yeah Wi-Fi you can connect our servers, right? Yeah, this is another model, client server model. Fine. So we can connect through desktop or laptop. Even you can use tab also to connect your servers through network. Fine. Yeah. So server architecture. Let's try to understand server architecture. So this is very important. So what is server architecture? So server architecture is the foundational layout or model of a server based on which a server is created and or deployed. It finds how server is the design is designed, right? So let's try to. This is very important for cloud engineers and DevOps engineers. Let's try to understand few examples. Yeah, server architecture. Initial phase of implementation. Initial stage of implementation. So this is the first phase of implementation. We can say first phase of implementation. So initial stage of implementation or first phase of implementation. So in 1990s or early 2000, how the organizations, how the organizations used to design the network. Let us try. This is very important. Okay, in 1990s or early 2000, how the project teams used to design the server architecture, right? Yeah. For example, I have four applications are there. Four applications like Java, Python, and C, C++, right? And Tomcat, right? So I have four applications are there. So these applications I want to host on server. I want to deploy on server. So in initial phase of implementation, first phase of implementation, how the project teams used to configure this, how they used to design the server architecture. Let's try to understand. In First phase of implementation. 90s, in 1990s and early 2000, how the project teams are, how the project teams used to design servers, right? Yeah. So these are the four applications, right? So for every application, they used to take one server. For each application, they used to take one server for server to design. So in 1990s and early 2000, initial phase of implementation, initial days. Okay, yeah. So four applications are there. The project teams are taking here four servers. For each application, they are taking one server like this. So in 1990s and early 2000, 1990s and early 2000, highest capacity of the storage is 1 GB by the time. Highest capacity of the storage is 1 GB, right? These are all 1 GB servers. Right? Yeah, so they used to take for each application, they used to take one server and they used to configure on the server. For example, here they deployed Java, right? So normally Java will take, for example, Java will take 300 MB of the size. For example, I'm saying. So remaining 700 MB space will be wasted, right? So it is 1 GB means 1000 MB, right? Am I correct? Yeah. So remaining space will be 700 MB will be wasted. Next one is Python. Python so occupied. So here 400 MB, for example. So remaining space will be wasted, right? Remaining 600 MB space will be wasted. And also C++. So occupied 450 MB, for example. So remaining space will be wasted. 550 MB will be wasted. So why we are discussing this? This is very, very important. So because in cloud, in AWS, we are going to work on servers, networks, right? Databases. That is why this is very, very important. So 550 MB will be wasted here. Okay. And also next one, Tomcat. Tomcat is one of the web server. Tomcat will take, for example, 500 MB. So remaining space will be wasted here. 100 MB will be wasted. Right? Yeah. So initial phase of implementation in 1990s and early 2000, the project teams used to take like this, right? They used to design like this. But here, what is happening? Yeah. So utilization is less, server utilization is less, but by the time hardware costing, it was very higher. So in 1990s and early 2000, server costing, hardware costing was very higher. So by the time even desktops also too much costing, 1.5 lakh. Desktops, laptops also too much costing by the time. So servers also too much costing. So that is why, yeah, server utilization is very less and costing is more. That is why this is completely failed. This concept is completely failed. So initial phase of implementation, first phase of implementation. So this was failed concept. That is why. So slowly, slowly, what happened in second phase of implementation? In second phase of implementation, what happened? So the project teams used to take high capacity servers. The project teams used to take one high capacity server. In that server, they used to deploy all the packages, all the applications like Java, Python, C++, and also Tomcat, right? So they, yeah, they started using. high capacity one server, they used to deploy all the applications on single server. So here what will happen? So Java user may access Java application. Python user may access Python application. C++ user may access so this application. So Tomcat user may access so Tomcat application. So all the users will access their respective applications. So here what will happen? So Java user may access Python application also. Python user may access C++ also. So yeah, this user may access Python also because all the applications are hosted in single server, right? Yeah, security will be there. Still, there may be chances to access other applications also. That is one of the drawback. And also, in case this server is crash, what happened? In case the service crash, all the applications will be gone, right? So here also some drawbacks are there. So first thing is security concerns, right? Second one is in case service crash, what will happen? All the applications will be gone. So
Can't save in OneDrive.
sorry, not.
I will save our
Yeah. So redundancy will be there. There may be chances. I'm saying, okay, drawbacks, some drawbacks. So here, for example, why I'm saying here, so Java user may access Python, Python user may access C++ like this. So for example, four people are staying in one flat. Okay, so two guys are staying in one bedroom, two guys are staying in other bedroom. So the four people commonly access kitchen and dining, right? Same way, so if you host four applications in same server, there may be chances to access other applications also, right? Yeah. So in case the service crash, entire applications will be gone. This is also failed concept. So that is why. So slowly, what happened? Virtual servers came into picture, right? So in third phase of implementation, so virtual servers came, virtualization. We can say virtualization. Virtual servers or virtualization. So what is virtual server? What is virtual server? So we take one physical server, high capacity server. So this we can say base OS, base operating system, right? So yeah, currently what we are doing, we are taking one physical server, so which is high capacity server. So on top of that, we are deploying one package, which is we can say VMware or hypervisor, Hyper-V or Citrix. So this is a virtual software. So this software is virtual software. So we take one physical server, which is a high capacity server, which is we can say base OS. So on top of that, we install one software, which is a VMware or hypervisor or Citrix. So once we install this software, what happened here? What will happen? So this will allow you to create virtual servers. This software will allow you to create virtual servers. So these are the virtual servers we can create. Yeah. So these are the virtual servers. These are all virtual servers. So different operating systems you can deploy on this virtual servers, right? So like for example, here I can deploy Windows 2016. Different operating systems you can deploy. So here I can deploy so RHCL, Red Hat Enterprise Linux. Here I can deploy so SUSE Linux, Linux version, different version, right? So here I can deploy Windows 2019. Here I can deploy Ubuntu. different operating systems I can install. Ubuntu, right? Yeah. So here these are the 25 servers, 5 into 5, 25. So based on based on your physical server capacity, we can create this virtual servers. So this is physical server, right? So based on your physical server capacity, we can create virtual servers as per the project requirement, as per the project requirement, right? So these virtual servers, these are all the virtual servers, right? These virtual servers can take the resource from this physical server. This physical server will have high computing power, like RAM, 48 GB, CPUs, CPU, you can say 32 core, and the storage HDD, we can say 15 TB, like that, 15 TB or 20 TB, like that, right? So these virtual servers can take the resource from physical server only from here, right? So this RAM will be shared. This RAM will be shared to virtual servers. These CPUs will be shared to virtual servers. This storage will be shared to virtual servers, right? Yeah. So currently, yeah, project teams are using virtual servers, but here also some drawbacks are there. So in this also drawbacks are there. What are those drawbacks? So for example, if you want to install operating system on a virtual server or physical server, so we are using ISO images. ISO images. What is ISO image? Anyone having idea? What is ISO image? For example, in your laptop, if you want to install Windows, what we will do? We can take one image into pen drive. That pen drive we can convert into bootable drive. So by using that bootable drive, we can install Windows, right? Same way, server side also, we can prepare one image which is ISO image. ISO full form is, yeah, international standardization organization. International standardization organization, right? So this is the master copy. ISO image is a master copy, right? So in this, all the features will be there, all the plugins will be there, all the drivers will be there, right? Yeah, this is the master copy. By using this, we can install operating system. So once we install operating system, all the features will be available. So this ISO image size would be minimum 6 GB to 18 GB. ISO image size would be minimum 6 GB to 18 GB, right? So for example, each server on an average, it will take 10 GB. 10 into 25 servers are there, right? So equal to 250 GB. We need to spend for only operating system, only OS, only operating system. We need to spend 250 GB. So on top of that, we need to install applications, plugins, patches, right? That will take more space, right? So we need to spend more storage for operating system as well as applications as well as plugins, drivers, features, right? So it will utilize more space. That is one of the drawback. So we are using more storage for virtualization, virtual servers or physical servers. That is one of the drawback. So and also when you restart or reboot both are same only. Restart or reboot server, it takes 4 minutes to 8 minutes. When you restart virtual server or physical server, it will take 4 to 8 minutes. That much of time client will not accept. Okay. So for example, Flipkart is running on a server. If the Flipkart is down for 8 minutes, what will happen? Em jaragachu? If the Flipkart is down for 8 minutes, what will happen? So Flipkart globally accessible, right? Flipkart application. If the application is down, business will be impacted. That is why client will not accept for 4 to 8 minutes, right? So currently we are using digital applications like Flipkart, Amazon shopping site, Mintra, Meesho, Reliance Trends. These are all digital applications. So if the application is down for 8 minutes, client will not accept, right? So yeah, client will be client escalations will be happened, and customers, if the application is not accessible, what we will do? For example, I want to book a product in the Flipkart is not working properly. What I will do? Eventually I can switch to other websites, Amazon shopping site, Meesho, Mintra. So many competition is there, right? So much of competition, so many websites are there. So that is why, yeah. So this is also another drawback. Client will not accept for 4 to 8 minutes downtime, right? And also one more drawback here is deployment time and the downtime is high. So what is deployment time? What is downtime? Deployment means when you want to deploy any applications, that takes more time. And when you want to down, what is downtime? Anyone having idea? What is downtime? Online guys, what is downtime? So downtime is nothing but maintenance time. Maintenance time, right? So if you down the server, applications will be down, right? So downtime is higher here. Okay. So when you down server, it will not restart immediately, right? So when you deploy applications, it takes some time. Deployment time and downtime is higher, right? So these are all drawbacks. That is why, so in fourth phase of implementation, currently we are using Docker containers. So Docker containers we are using. So you can say Docker architecture. Currently we are using Docker containers. Let's try to understand Docker architecture. Docker architecture is very advanced one, very important one. Currently, every project team they are using Docker infrastructure, Docker architecture. So this is very advanced. This is the trendy. Currently, project teams are using Docker architecture, right? Yeah. In Docker architecture, what we will do? Same as virtual environment, same as virtual servers, same as virtual architecture. So we take one server, which is a Docker server, which we can say this is a AWS server, for example, AWS server. Okay, you can take one AWS server. On top of that, what we will do? We can deploy one package, which is we can say Docker image. Docker image. So on top of that, what we will do? We can create Docker containers. So this is very advanced infrastructure. So currently most of the project teams they are migrating to Docker because of so many features are there, so many advantages are there. These are the Docker containers. This is the latest one. Okay. Yeah. So here we can deploy different operating environment like virtualization. So here I can deploy RHCL, Red Hat Enterprise Linux, and here I can deploy Ubuntu. Here I can deploy Windows 2012 R2 or anything. So here I can deploy 2019 Windows, right? So like this, whatever you want to, you can deploy operating environments here, operating systems. So when you run the container, when you create the container, what will happen? So in this only bin and lib files will be available. Bin and lib means binary and library. Bin and lib means binary and library. So when you run the container, only binary library files will be available. So when you deploy operating system, it will take 200 MB of this size, only 200 MB. So it will occupy only 200 MB for operating system. But here, whereas virtual servers, how much size? 6 GB to 18 GB. But here only 200 MB. So when we configure, when we deploy operating system, only 200 MB will be occupied. And also when you restart or reboot containers, okay, it takes 15 seconds only, just 15 seconds, 15 seconds. Okay, when you restart or when you restart your container or when you reboot or container, when you reboot your container, it takes 15 seconds only, very less time. So even, yeah, for example, one developer is working on the container. So when you restart container, it doesn't understand whether it is restarted or not. Very quickly it will be restarted. Okay, and also deployment and downtime is very less. Deployment time and the downtime is very less. When you deploy any applications on containers, so very quickly, very faster, those will be deployed. So when you restart your container, when you down your container, so immediately it will be back to normal state, right? So Docker containers are advanced to virtual servers. Docker containers are advanced to virtual servers. So currently, most of the project teams, they are migrating to Docker infrastructure, Docker architecture, because currently we are using digital applications like Flipkart, Amazon shopping site. So these are the digital applications, right? So when you book any product, so the product will be delivered within 10 minutes also. Groceries, right? So when you book groceries, within 10 minutes they're delivering because of backend containers are there. Docker containers are there backend. So when you book any mobile or any electronic item, that will be delivered within a 1 day or within 4 hours also sometimes, right? So because backend, so high capacity, yeah, high capacity servers like high capacity containers are there, right? Yeah, so this is very trendy currently. Yeah, most of the project teams, they're using Docker infrastructure. So already 50% of the project teams implemented Docker. So whoever not implemented, they're implementing now. Docker is having very high demand currently. Docker containers, right? Yeah. So if you put Docker or Kubernetes in your resume, you can easily crack your interview. Docker or Kubernetes. Kubernetes is advanced Docker. So Kubernetes is advanced Docker. So Docker is very advanced. Kubernetes is very advanced Docker, right? So Docker and Kubernetes are very, very important. So if you put in your resume, so you can easily crack your interview. You get more calls, right? Yeah. So Docker launched in 2013. Docker implemented in Docker started in 2013. So immediately after 1 year, Kubernetes launched 2014. Okay, yeah. So Kubernetes will discuss later. Okay, next one, Docker. Before Docker also some containers we used to use. Before Docker also we used to use some containers, right? So Docker is a latest one. Before Docker also we used to use some containers. Before Docker. Before Docker, what are the containers we used? LXC, LXC. It is a Linux container, Linux container. So second one is Jones. It is a Solaris container, Solaris containers, and LMCIFI, LMCIFI. So the full form here is Let Me Container for You. So this is Google container. So before Docker, we used to use this containers, but these containers are failed. These containers are failed. So these contests are failed. Why these contests are failed? Because of these contests are failed because of these are all platform dependent containers. These are all platform dependent containers. So these are all platform dependent containers. That is why these containers are failed. But Docker is not platform dependent. Docker is not platform dependent, right? So Docker is platform independent. So these are all platform dependent, right? So Docker is not platform dependent. Docker is platform independent. Why Docker is platform independent? So irrespective of yeah. So here Linux will run on LXC will run on Linux only. Jones will run on Solaris only. LMCI FI will run on Google only, right? So respective platform only, but irrespective of operating system, Docker will run on any platform like Windows, Linux, Solaris. We can run any platform. We can run Docker on any platform. So which is nothing but platform independent. So Docker will run on Windows, Linux, Solaris, even though Mac OS also, we can run Docker. So that is why what we are saying here, yeah, this is a platform independent. It is a platform independent. So these are the platform dependent. Docker is platform independent. That is why Docker is very popular now. So most of the companies they are using Docker. So moreover, Docker licensing cost is very less. Licensing cost is very less, right? So client always look for the cost saving. So when you go with the virtual servers, so it's more costing. When you go with the Docker, less costing, right? So very higher speed. Docker is very faster, right? So time will be reduced, cost will be reduced. That is why most of the companies they are using Docker infrastructure. So when we start working on the Docker, we'll go deep dive. Docker will take, yeah, so nearly 10 days, nearly 8 to 10 days will take Docker. Nearly 8 to 10 days it will take. So Docker will go deep dive, right? So while working on Docker, yeah, from basic level to advanced level, we'll go deep dive. This is just high level architecture. Clear, right, everyone? Any questions up to here? This is advanced one. So Docker is very, very important. So it is very easier also to learn, right? Yeah. Clear, right, everyone? Up to here? Yeah. Right. Fine. Next one is, yeah, these are the four types of implementations available. So first phase of implementation, second phase of implementation, these two are failed. These two are failed. Yeah. So third phase of implementation, still people are using, still project teams are using, but still we have some drawbacks are there, right? So that is why they're migrating to Docker infrastructure, Docker architecture, right? This is the latest one. Fine. Now let us move back to, yeah. So this is Docker, this is architecture. So while working on, yeah, Docker will go deep dive. Okay. Next one, what is the operating system? Operating system. What is operating system? Anyone? Anyone having idea what is operating system? So here we discussed base OS, right? Base OS, what is this? Base operating system, right? Yeah, so without operating system we cannot run the server, our laptop, our desktop, right? Yeah, what is operating system? So operating system is a, for example, in our laptop we have hardware, right? So hardware understand binary language only. Binary language. What is binary language? Anyone? What is binary? Zeros and ones. Zeros and ones, right? But a human user will not understand binary language. We cannot understand binary language, but a hardware will understand binaries only, right? So we cannot understand binaries. That is why we require one translator. We require one translator to understand binary language. So operating system is a translator. It is a mediator. It is a interface to translate binary language to, yeah, binary language to human readable language to hardware, right? So hardware will understand binaries, human will not understand binaries. That is why operating system it will convert binary language to human readable language and vice versa for effective communication. See here, this is the definition. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. Right? See here. So operating system is in the middle, right? So it will convert binary language to end user to binary. So vice versa. Fine. Next one is the types of operating systems. Types of operating systems. First one here is single user, single tasking operating system. Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform one task only. Single user, single task, right? So for example, here it is MS-DOS, Microsoft Data Operating System. Microsoft Data Operating System, which is very old operating system. In this operating system, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system. Second one is single user multitasking operating system. In this type of operating system, only one user can log into the system. He can perform multiple tasks at a time. So, which is nothing but Windows. For example, while browsing internet, we can run background audios, right? While working on any task, we can run audios. So one user can log into the system, you can perform multiple tasks at a time, right? Which is Windows. Next one is multi-user multitasking operating system. So multiple users can log into the system, they can perform multiple tasks at a time, which is nothing but multi-user multitasking operating system. So for example, here Linux and Unix, right? So Linux will support multiple users to log into the servers and they can perform multiple tasks at a time. For example, in real-time projects, while deploying the application, developers will log into the servers, testers will log into the servers, DevOps engineers also will log into the servers. They perform their respective tasks, right? Which is nothing but multi-user multitasking operating system. So currently, most of the project teams they are using Linux servers only. Backend they are using Linux servers. So Linux servers are having high security. So in Linux we don't use GUI CLI. You understand, right? You know, right? What is GUI? Anyone? What is GUI? GUI and CLI. GUI is a graphical user interface, right? CLI is a command line interface, right? So in Linux, always we use CLI, right? CLI is more secured compared to GUI. Windows is GUI, right? Windows is GUI. Yeah, Linux is CLI. Linux is more secured because CLI, command line interface. So we don't get any viruses in Linux. We don't get any threats. We don't get any malwares in Linux. So Linux is more secured. Linux is more faster, right? So Linux is having more features. That is why every data center, every project team, they are using Linux servers currently, right? So we have Linux sessions also, right? Once we start working on AWS, sure. So once we start working on AWS, yeah, we have Linux sessions also. So 4 to 5 sessions we have Linux sessions. So those are Linux basics, Linux architecture, Linux folder structure, Linux user management, Linux file permissions, Linux filter commands, basic commands, advanced commands, deployment commands. So this will be covered. These are will be covered. So we are not Linux admins. We don't require all the concepts. We don't require admin concepts, right? We are not Linux admins. So yeah, currently Linux admins not there in the market. No admins. Admins already gone. We are DevOps engineers. Whatever services we required, whatever commands we required, whatever concepts we required, those will be covered in our course. Fine, clear, right? So these are all the yeah. So to here we yeah networks we'll discuss tomorrow, and someone asking some question in Docker terminology. Yeah, we'll discuss. Wait for some time. While working on Docker, we'll go deep dive. So this is just architecture, high level architecture. While working on Docker, we'll go deep dive, right? From basic level to advanced level. Fine. Any questions up to here? Anyone? So tomorrow we are going to discuss about networks, networking, networking part, which is very very important. So networking will take 1 hour, right? So tomorrow we are going to work on networking. So tomorrow also theoretically we can understand theoretically, right? Yeah. So after that we'll jump into AWS slowly. Fine. So our sessions more into practical oriented, more into practical. So these are the introductions. These are the basics. That is why we are discussing this. So once we start working on cloud, yeah. So every day practically we'll see the concepts practically, right? So you need to practice daily basis. If you practice daily basis, you can easily crack your interview within 3 months. Within the 3 months you'll get the job. So you need to practice daily basis, right? So one hour live session you need to attend, and 2 hours you need to practice, so that you can easily crack your interview. You can easily cope up in the projects. Clear, right, everyone? So anyone having any questions? I gave you unmute option. If anyone having any questions, you can ask me now. Fine. Yeah. So everyone, small announcement here. We are planning to change the timing to 8 a.m. IST. Is it fine for you, everyone? We are planning, not yet confirmed. So because people are unable to attend early morning, right? So that is the few people expressed that. So those who are attending from other countries, from US and Australia, few people are attending. So are you okay for this? 1 hour, yeah, just 1 hour late. So like currently, yeah, we have session 7 a.m. IST. So next, yeah, we are planning actually, not yet confirmed. 8 a.m. IST is fine for you, everyone. 8 a.m. IST. Yeah. So we are planning actually. So because this batch nearly 30 members are registered. Okay. Actually, every batch minimum 70 members. So because of timings, because of early morning, right? That is why. So planning to change to 8 a.m. IST, 1 hour late, just 1 hour. Okay. So yeah, US people, maybe you have 9 p.m. IST. Yeah, 9 p.m. IST or 9:30 p.m. IST. Is it fine for you? Few people are there from US. Okay, someone saying need to go to office at 8 a.m. Okay, fine. Yeah, Srilata, can you WhatsApp me after the session? We'll discuss. Srilata, can you WhatsApp me after the session? We'll discuss once. Srilata, yeah, fine. Yeah, everyone saying okay. Only one person saying ATM office is there. So we'll see that. We'll discuss, and accordingly we'll see that. Okay. Yeah. Fine. Yeah, we can stop here. Tomorrow we are going to work on networking. Fine. Yeah, we can stop here.